Good afternoon, everybody. So we are starting on page 30 of your module booklet. Page 30 says volcanic hazards at the top. So if you don't have page numbers because you've printed it off the internet, then volcanic hazards, it's actually duplicated as a title for reasons I can't really tell you other than I was in a bit of a rush, really. Okay, so volcanic hazards. We're going to start off with some terminology, some words that are really quite important, and they are the words on the screen at this moment in time. I would suggest that you might want to write those on page 30 or in your notes or whatever it is you're doing, but they're very, very important words. So anything that has the potential to cause harm is a hazard. So a wet floor is a hazard because you could slip over and really hurt yourself. A volcano is a hazard because when it erupts it could damage people and property. There are loads and loads of hazards in the world. It's anything with the potential to cause harm. The chance of harm occurring is the risk. Okay, so the easiest way to think about risk, let's take the example of geography field trips. If I was to take 17 people on a field trip, that's lower risk than if I took 50 because there are fewer people to be potentially harmed on that field trip. Okay, so risk is affected by loads and loads of different factors when we're talking about volcanoes, but fundamentally, for now, if you accept the fact that if you had two very similar volcanoes and one of them was in a city where there were millions of people, for example, like Vesuvius is right near Naples, there are millions of people in harm's way. That's a very high risk. Whereas we've talked about Chaiten in South America before, and Chaiten is a volcano in a not very densely populated place, so it's much lower risk. So if we just kind of go with that for now, and then right at the end of this section we will talk about other things that affect risk. So our topic for the next couple of videos is all of the different ways that volcanoes can cause harm. And you've got a diagram on page 30 with a few words and phrases that I'm going to be talking about in these videos. Can I just emphasise that there is not one single volcano on planet Earth that is capable of producing all of those hazards, thank goodness. They are all different, they all have different characteristics because, of course, the location that they are in dictates the lava type, and the lava type dictates everything else about them. But I will try to emphasise that as we go through. Final bit of terminology before we really get to grips with these specific hazards. Primary and secondary. Now we use those words a lot in geography, and the last time that we encountered them was in the Changing Places module, where we were talking about the different kinds of jobs that people do. So we talked about the primary sector, which is farming, fishing, forestry, etc. The secondary sector, which is making things. The tertiary sector, which is services, and so on and so forth. They are named after the order that those jobs kind of were created in. Primary first, secondary second, and so on. Exactly the same as your education. Well, sorry, for those of you that have been to school in the UK, we have primary school, followed by secondary school, and then you have your tertiary education, which is university, and so on and so forth. It's all about the order that things happen. Okay, so if we now apply it to hazards, if something is described as primary hazard, it's immediate, direct. It happens and it affects things. So there's like one link, if you will. Okay, so if we take a lava flow on this diagram, lava flows can burn your house down, they can hurt crops, they can hurt people if people don't get out of the way. They are a primary hazard, they will directly cause problems. Then we have secondary hazards, which is like one step removed. which is where the kind of second bit comes in. Something has to happen first, and then you get a secondary hazard. So if I use the example of climate change, so the primary hazard would be the eruption cloud, the ash cloud created by the eruption. So that's a primary hazard. If that then has an effect on climate, that's a secondary hazard. It's kind of one step removed. That will probably become more obvious once I've explained the hazards to you. But pause if you need to. Before we go any further, I want you to have written down definitions of hazard, risk, and the difference between primary and secondary hazards. Okay, then don't worry, this is a really nice, easy task. It involves potentially a little bit of colouring, but you can do it differently if you want to. For the next 2 videos, what I'm going to do is I'm going to help you fill in the table on pages 31 and 32. Okay? What I want you to do so far is come up with some kind of coding system to clearly separate the primary and secondary hazards. So the primary hazards are lava flows, pyroclastic flows, ash cloud, bombs, gas. The secondary hazards are lahars, landslides, tsunamis, jokulhaups, and climate change. So you could either give them a different colour, you could use the letters P and S, you can have symbols, I'm really not bothered. But could you please, before you go any further, have some kind of system? And then what we're going to do together, we're going to fill in the first 2 columns, the description and the case study columns, but can you ignore the 3rd column for now? I will explain that when we get to the end of this section, so probably at least another 2 or 3 videos time. All right, trust me, leave the 3rd column blank for now. Okay, right, pause if you need or crack on, whatever you want to do. Okay, so I'm going to say this point. This PowerPoint is full of hyperlinks to videos and news stories and things, absolutely full of them. I'm not going to open them because it's going to make this video ridiculously long and it will just annoy you. So as ever, if you find this PowerPoint in OneDrive, it's in a hazards folder and the actual PowerPoint is called volcanic hazards. If you find that, you've got this exact PowerPoint and you can open all the hyperlinks for yourselves. I think watching those additional videos and looking at the website's news stories will really help you. It's just that it would take up too much time. This clip is it's a very nice relaxing one actually. It's about 7 minutes and it's video footage of lava flows, which are beautiful in my opinion, and it's narrated by Benedict Cumberbatch, and it's just a really nice little watch. It won't really tell you anything that you don't know, it's just a really nice little video to watch. So that is the kind of stuff you're going to put in your description box, okay? We know, don't we, that it could only be mafic magma that could do this because silicic magma is not going to be able to run. So it's only mafic magma. And the key thing to emphasise is really the 3rd bullet point. People are not usually killed by lava flows because they get out the way. They do not generally flow very fast at all. Houses, buildings, can't move. So they will destroy anything that cannot get out the way. So that is a house on the slopes of Mount Etna, actually. That is a photo I tried to take out of a coach window, which is why it's a bit blurry and not very good. The hyperlink above is of a lava flow moving in Hawaii, just to prove that really people, shouldn't get hurt by them really. Sometimes they do, but you can clearly see that you could get out of its way. This photo and clip is of a house being very slowly destroyed by a lava flow in Hawaii. It just proves that anything that cannot get out the way will be set on fire and destroyed. Now, because I'm a bit of a strange person, I have deliberately chosen your case study as the only volcano whose lava flows do kill people. And I know that makes me a horrible person, sorry, but it's just a really interesting volcano. So it's pronounced Nyiragongo, and it's in the Congo, which is brilliant. Now that YouTube clip, it is not essential for you to watch, actually. It's really interesting, but it's not crucial. It's from a documentary presented by Richard Hammond, and they're there filming this volcano, Nyiragongo, and there's a very stupid person who does survive. I am not showing you a video of somebody being killed by a volcano, that would be horrific. He does survive, so I'll tell you that, but oh my gosh, he is a bit of an idiot about this volcano. So it's just for sort of entertainment. Now I'm going to put there we go. Please don't try and copy all of that into the box. Pick 2, maybe 3 of those little facts. Please do not copy them all. You do not need to. But in 2002, Nyiragongo erupted, and this is the important bit. Lava does not usually travel that quickly, and I think you would agree that you are not getting out of the way of that. You know, you don't stand a chance, do you, against 70km/h lava. I mean, it's just horrific. It led to forced migration, so that's a nice little link to other stuff we've learned about. And here it is. So Nyiragongo, look here, it's all part of the Rift Valley complex that's happening in East Africa that we've talked about in plate tectonics. So we've got a divergent margin because magma is coming up underneath East Africa, and East Africa is being ripped apart, and Nyiragongo is one of the volcanoes linked with that sort of complex, as it were. And there are some photos of the destruction that the lava flow caused in a town called Goma. So yeah, that's your little case study. Remember, we're leaving the third column blank. Right, these things are scary. Pyro, P-Y-R-O, fire. Clastic, if you're a geologist, you know, a clast is like a piece. So pyroclastic is fire pieces. Pyroclastic flow, it's a flow of pieces of fire, sort of thing. What it is it's a very hot, very fast flow of solid material. These are super scary, awful things. There is a YouTube clip at the bottom, which is one of the most famous videos of pyroclastic flows ever taken. It's for a volcano called Mount Unzen, something like that. It's spectacular footage, it really is. It's sort of, you can't even imagine. So pyroclastic, it's a flow of hot pieces of rock. Okay, so you can put that in your own words in the description box. But what I do want you to emphasise is that these are dangerous to people, to everyone. You are not outrunning these. You haven't got time. They will destroy everything, not just the things that can't move, because nothing can get out of the way of something travelling at 700km/h. So these are super, super scary. And what you can see here is they kind of remind me of tornadoes. I know we don't learn about tornadoes, but where a tornado travels, the exact path it takes, everything is destroyed, and yet kind of like 3-4 metres away, the house next door is fine. It's very strange. And look, that's kind of like pyroclastic flows. Everything in the path, nightmare. Next door, not too bad. Really strange. So pyroclastic flows, very scary. Now, we are not going to say very much about your case study for these today, because by the end of this week, I will be telling you that your 2 main case studies for volcanoes are the Soufriere Hills volcano on Montserrat and the E15 volcano in Iceland. So for now, we're just going to say a teeny tiny bit. Montserrat is very famous for its pyroclastic flows. 19 people died. It actually or they actually changed the shape of the coastline of the island because it's a small Caribbean island and the pyroclastic flows flowed out to sea actually changed the shape of the coastline. So they're quite remarkable things. And a combination, to be fair, of pyroclastic flows and ash, which I haven't talked to you about yet, but so bad is the situation on the island of Montserrat that their capital, which is called Plymouth, is completely uninhabitable. This is a very, very famous photograph, and you can see it's just completely destroyed. So, yeah, don't underestimate a pyroclastic flow is today's message, folks. Okay, now you can see my very well drawn little red cross. So, pyroclast, fire piece, is a kind of geological term. We are not interested in geography about lapilli. Lapilli are like the medium-sized ones. We're not interested in medium-sized. We have to learn about ash and lava bombs. So the only difference between ash and lava bombs is their size. Ash is still solid pieces of rock and glass. Lava bombs are just much bigger, so they are fundamentally the same thing. And I think I've said this to you in a previous video, but the thing that we absolutely cannot afford to do is to think of ash as being something soft and fluffy, like when you burn paper. It is absolutely not that, okay? So some people find this picture quite useful because it makes them think, oh, so it's just like a lava bomb, but just much, much, much smaller, and that might just help you, okay? So, I've kind of emphasised this far too many times. It is not the same as soft, fluffy ash. It's just one of those misconceptions that we don't want you to have. This is formed in explosive eruptions. Remember, the magma in the magma chamber is molten rock. But what happens, and this is where the Ed Byrne video came in, where Ed Byrne goes to Bristol University. If you have no idea what I'm talking about, you need to go back and make sure you watch the Ed Byrne bit because it will make a lot more sense. So what happens in a silicic magma volcano is that the volcano explodes. At the moment it explodes, the molten rock instantly solidifies into something called pumice, which is a solid rock. And then the force of the explosion blasts the pumice into tiny little pieces, which is where you get your volcanic ash and other things from. So lava flows mafic, volcanic ash silicic. Notice that it constantly comes back to what kind of magma or lava you had. So we've kind of been over that. The thing to really know about here is why volcanic ash is so dangerous to aeroplanes, okay? And there is a little video link in the middle of that slide which is really, really helpful for explaining that to you. There are actually quite a few documentaries about this on loads of different places, YouTube, Netflix, whatever. So you could definitely spend a little bit of time. The reason it's important to know about ash clouds and aeroplanes is because if you have an eruption which causes an ash cloud, the possibility is that it will not just affect the country that the volcano is in, because once the ash is in the atmosphere, it could potentially travel to loads of different places. And if you know anything about Icelandic eruptions already, you will know that when the ash cloud from 2010 happened, there were no flights across Europe. At that point, we thought that was very unusual. 2020 has proved otherwise, but there were no flights in Europe, and it was all because of this quite tiny volcano in Iceland, to be honest. So it's the idea that volcanoes can have international impacts, and that generally is to do with flights and aeroplanes and things like that. So please watch that clip. Again, we're not going to say very much about the case study at this particular point because you are going to really get to know E15 well. Why do I call it E15? Well, I can just about pronounce it. It's Eyjafjallajökull. I'm not brilliant, but I'm okay at that. It's quite hard to spell in exams. It's quite difficult to say. It begins with an E. It's got 15 letters. Okay, so that's where E15 comes from. But that will be your other big case study. For today, you could just put that in the box, and you can see that there's a little clip there about it if you would like to watch. So that's roughly where the ash cloud travelled, closed most of European airspace, and lots of problems. Right, lava bombs. So as I've already said, the only difference between ash and a lava bomb is their size. You've got a person in that photograph for scale. They can be massive things. Now this photograph is not one of mine, but it is on an island called Stromboli, which I am lucky enough to have visited, and it's Europe's most active volcano. It erupts pretty much every day, and I think it was last year. I think so. There was a man unfortunately killed by one of these lava bombs on Stromboli, so I've put the news story there for you to have a look at. You can sort of imagine, can't you, that if this was thrown out of a volcano and landed on you, you don't stand a chance, do you? I mean, it's game over, fairly obviously. They are very dangerous things. And this is a video of lava bombs being chucked out of a volcano, but luckily at a safe distance. And it just gives you a sense of their magnitude and their power and their speed and everything. So definitely, if you're unlucky enough to be hit by one, it's game over. But the risk, using that word, is generally quite low because people are not often close enough to a volcanic eruption to, be hit by a lava bomb. They can cause damage. Sort of, understatement, isn't it, really? So, sorry, the case study is just a little bit of information about Stromboli from there. You don't need to know much about lava bombs because there's not very much to say about them, really. Okay, which brings us to the last of the primary hazards, gas. So, do not write all of these down, please. Pick 2, maybe 3. Some that you recognise, some that you've never heard of. I don't know, really. Some of those we've talked about before in the water cycle, in the carbon cycle, in life in general. So, like I say, for description, you can just pick 2. Volcanoes produce gas constantly. In a mafic magma volcano, that gas is going to be constantly released because there's no build-up of pressure. And in a silicic magma volcano, those gases are going to build and build and build and build until you have an almighty explosion, as we've talked about. So, water vapour, you know about water vapour. It is a greenhouse gas, but it's not one we talk about very much because humans don't really have any control over it, so it's not one we can tackle very much. Carbon dioxide, you know about from the carbon cycle, definitely a greenhouse gas. Sulfur dioxide is the one that smells like rotten eggs. And then some of them become particularly deadly. So for example, hydrogen chloride can cause irritation. Exposure to high levels could cause corrosive damage, which could lead to pulmonary edema, which is a build-up of fluid in your lungs, not good, and even death in extreme cases. I've also included a hyperlink there to hydrofluoric acid, so hydrogen fluoride and its effects. So some of these gases are not too much of a disaster, and some of them would kill you pretty, nastily. And the thing about volcanoes is each of them has its own sort of autograph signature, if you like, in terms of the gases that it produces. Different volcanoes, different ratios of these gases. But all volcanoes produce gases all the time. It just depends whether they're constantly emitted, mafic magma, or emitted after explosions. So, a little bit like lava flows, I'm going to give you your case study of a very weird one, a bit of an anomaly, if you like, but it is very famous. So Lake Nyos in Cameroon Okay, so here's a little diagram of Lake Neos. It's a volcano with a crater, and the crater is filled up with water. That happens a lot. Lots of volcanoes have crater lakes because the rock is impermeable, so the water cannot percolate through it. So as the rain falls out the sky, you end up with a lake. It's a kind of fairly obvious thing. Now, the jury's out and there's lots of arguments, so please don't get too bogged down in this case study because it is slightly controversial in some ways. But essentially, we now know that there was a volcanic eruption, but they didn't know that to start with. There was just an area of Cameroon where loads of people and animals were found dead with no signs of a struggle, no blood, just loads of dead people and dead animals. Which would be weird, you have to admit, wouldn't you? That would be very, very weird. So obviously they had to try and piece together what on earth had happened to these people and these animals. And they worked out in the end from the lake. So you can see the photo on the left-hand side, the lake looks fairly normal. And then on the right, something's definitely changed. There's a lot of suspended sediment, it's very muddy, something has happened. And what they now believe is that there was an eruption of gas. So a massive eruption of carbon dioxide is what they think happened. And because carbon dioxide in high concentrations is denser than the air, gravity took over and it flowed down the side of the volcano in a 50-metre thick cloud. And what it did is it suffocated everything in its path until it just diffused into the atmosphere. It was like kind of the perfect assassin because there was no evidence left of this cloud of CO2 because it just dissipated into the atmosphere. So that's what they believe happened. There are quite a few theories saying other things, but that holds the most sway, if you like. So that is an eruption of gases. And that marks the end of our primary hazards, ladies and gents. So, remember, all I wanted you to do at this point is to fill in the table, the first two columns. We are going to come back and talk about the third column once I get to the end of the secondary hazards video. So I haven't forgotten, we're just not quite there yet. Okay, thank you.